Let's talk about a mineral that most people know is important, but few truly understand in terms of its profound impact on immune function, especially as we age. Zinc. And I need to be direct about something here that makes some people uncomfortable. The form of zinc in your diet, whether it comes from animal or plant sources, dramatically affects whether you actually meet your body's needs for this critical nutrient. Zinc plays essential roles throughout your body. It's required for immune cell function, wound healing, protein synthesis, DNA synthesis, and cell division. But as you age, your immune system undergoes a process called immunosenescence, essentially a gradual decline in immune effectiveness. You become more susceptible to infections, your wounds heal more slowly, your vaccination responses weaken, and chronic low-grade inflammation increases. Adequate zinc status doesn't prevent aging, but it significantly impacts how well your immune system maintains functionality despite the aging process. Here's the uncomfortable biochemical reality. Zinc from animal sources, particularly red meat, oysters, and pork, is absorbed at substantially higher rates than zinc from plant sources. The issue is phytate, a compound abundant in whole grains, legumes, and nuts that binds zinc and prevents its absorption. You can consume impressive amounts of zinc from plant foods on paper, but if it's largely bound by phytates, your actual zinc absorption and status may remain inadequate. This is measurable in research. Vegetarian populations, particularly those relying heavily on whole grains and legumes, consistently show lower zinc status than omnivorous populations. The immune implications of this are substantial. Studies on elderly populations show clear correlations between zinc status and infection resistance, particularly respiratory infections, which become increasingly dangerous with age. Adequate zinc supports the development and function of immune cells, helps regulate inflammatory responses, and maintains the integrity of barriers like skin and mucous membranes that prevent pathogen entry. Zinc deficiency, even marginal deficiency, impairs all of these functions. But here's where I need to issue a strong warning. Zinc supplementation isn't benign. Taking too much zinc, particularly in supplement form, creates its own problems. Excessive zinc intake interferes with copper absorption, and copper is essential for iron utilization and connective tissue health. Long-term high-dose zinc supplementation can actually induce copper deficiency with serious consequences. Additionally, zinc supplements can interfere with absorption of certain antibiotics and should be timed carefully around medications. And if you're taking both iron and zinc supplements, they compete for absorption and should be taken separately. The practical approach requires some thought. For omnivores, consuming zinc-rich animal foods several times weekly typically ensures adequacy. Oysters are extraordinarily zinc-rich, though not everyone has access or taste preference for them. Red meat, poultry, and pork provide substantial amounts. Eggs and dairy contribute some, but not as much. For plant-based eaters, the challenge is more significant. Soaking and sprouting grains and legumes reduces phytate content and improves zinc bioavailability somewhat, but likely not enough to match animal source absorption. Supplementation becomes a more critical consideration for older adults, particularly those with restricted diets or increased needs due to chronic illness. The key is appropriate dosing. For general immune support, 15 to 30 milligrams daily is typically sufficient and safe. Higher doses should only be used short-term under medical guidance. And always take zinc with food to minimize gastrointestinal upset. The seasonal timing matters too. During cold and flu season, ensuring optimal zinc status could make the difference between weathering minor infections quickly versus developing more serious complications. Some evidence suggests zinc supplementation at the onset of cold symptoms can reduce duration and severity, though the evidence is mixed and dosing matters. What we're talking about here fundamentally is immune resilience. The ability to resist infections, recover from illnesses, heal wounds, and maintain robust immune surveillance against cancer cells. All of these functions depend heavily on adequate zinc. And the bioavailability differences between animal and plant sources make this more than an academic distinction. It's a practical reality that affects your immune health trajectory as you age.